Hello everyone. In this session, I'm going to introduce the topic which is very important, trigonometric ratios, basic introductions. Like what are the different types of measuring angles that we have? What are the quadrant signs? We're going to see what is the particular values of trigonometric ratios. What is the domain and range of a trigonometric function? This actually we need to see after sets, relations, and functions. But with a small introduction, you can understand what is domain, what is range of trigonometric functions. Okay, without any delay, let us dive into the topic. First, you should understand what is angle. Angle is a measure of rotation of a given ray about its initial point. Okay, just see here. Suppose I have this is initial ray. I turned this up to here. Okay, this is the initial position. This will be the terminal position or final position. The original ray is called, they are calling as a initial side, and the final position is called as a terminal side, whatever. And the position of rotation is called as vertex. This is known as vertex. Okay. If the direction of the rotation is anti-clockwise, this is a very important thing. You already know what is angle is, but the angle, which direction you are taking is very important. If you are taking it in anti-clockwise direction, you need to take in positive. Okay, the angle will be positive. If you are taking in a negative direction, like clockwise direction, you need to take the angle in a negative. Here you are turning in a anti-clockwise, so this is positive theta. Suppose you are turning it like this down in a clockwise direction, here you will take the angle like minus theta. The same thing they have given here. They turned it complete 360 degrees in a positive direction. They turned it 180 degrees in a positive, mean anti-clockwise direction. They turned it 270 degrees in a anti-clockwise direction, so it is positive 270. Here also 420 degrees positive direction, like anti-clockwise. But you just see this is minus 30, they mentioned that because they are going in a clockwise direction. And again this minus 420 because they are going in a clockwise direction, the angle they are writing as negative. This you should understand the direction of the rotation. Direction of rotation is very important. Okay, now let us see what are the types that we are using currently to measure the angle. One is degree measure. What is degree measure? A complete circle we are dividing into 360 equal parts. Okay, like this 360 equal parts we are dividing, and each part we are calling as a degree. Each part we are calling as a degree. Okay, complete circle is nothing but 360 degrees. Further, what they did, each part again they divided into 60 equal parts. Each part is known as minute. So 1 degree is 60 minutes. 1 degree is 60 minutes. Again they further divided 1 minute also into 60 seconds. 1 minute they further divided into 60 seconds. This is a degree measure. Then we have one more number system, that is circular number system. The scientists, the mathematicians, they discovered at the very beginning, you take concentric circles, measure the radius, equal length of arc, which is equal to the radius you take, and the angle formed by that particular arc and the radius, there is a relation between these three elements. Okay, or else you just take another one, a bigger one. For that also you are getting the same constant number. For the another one also you are getting the same constant number. So they found a relation between the radius and length of the arc and the angle between them. That is nothing but theta is equals to L by R. Length of the arc divided by radius. Okay. Is that clear? Yes. The radian is the angle subtended by the center of circle by an arc. At the center of the circle by an arc whose length is equal to the radius of the circle. We will denote 1 radian as like this. 1 radian. This is 1 radian. 2 radians. Okay. Yes. Now, what is the relation between the degrees and this circular system, radian system? That we'll see here. A complete circle subtend its center an angle whose measure is 2 pi radians, that is 360 degrees. How? It's very important. Just try to understand. I am taking a unit circle. What is meant by unit circle? The radius of the circle is 1 unit. Okay. Radius of the circle is 1 unit. Okay, very good. Then what will be the circumference of this circle? I'm talking circumference. Circumference is 2 pi r. 2 pi into radius is 1 unit, which is nothing but 2 pi. A complete circle is nothing but 360 degrees. So that's why 2 pi is nothing but 360 degrees. Okay. 2 pi is 360 degrees. Hence pi radians is 180. Send this to another side. Pi is equals to 360 divided by 2, which is nothing but 180 degrees. So pi is equals to 180 degrees. You can call it pi as 180 degrees. Okay, keep it in the mind. Then what is 1 radian? This pi radian you will write as pi into 1 radian, which is 180 degrees. So 1 radian will be nothing but 180 degrees divided by pi. Pi is nothing but the same thing again, 22 by 7 only. If you divide further, you will get 1 radian as 57 degrees, 16 minutes, 21 seconds approximately. Okay. Then what is 1 degree equals to? We know 180 degrees is pi radians. This 180 degrees I'll write as 180 into 1 degree, which is nothing but pi radians. So 1 degree is nothing but pi by 180. Okay, pi radians by 180. These two we will use. This one and this one we will use to convert from radian to degrees and degrees to radian. Just see here some example. I have 120 degrees. I have 120 degrees here. Try to convert it into radians. How we will convert? 120 degrees we can write as 120 into 1 degree. We know that 1 degree is nothing but pi by 180. Okay. So what I will do here? 120 into pi by 180. Or else multiply the given angle, degree, given the given angle with pi by 180, you will get radian. 0, 0 cancel. 6 3s, 6 2s. So you will get 2 pi by 3. Okay. 150, how you will convert? Multiply the given angle with pi by 180. 0, 0 cancel. 3 6s, 3 5s. So you will get here 5 pi by 6. This is how we will convert. Yeah, let us see some examples over here. What is pi by 2? Just instead of pi, you substitute 180, you will get the answer. 180 by 2 is nothing but 90 degrees. That's it. Pi by 3 means 180 by 3, which is 60 degrees. Pi by 6 means 180 by 6, which is 30 degrees. Pi by 4 means 180 by 4, which is 45 degrees. 3 pi by 2. What is 3 pi by 2? You just substitute pi value 180. 2 90s, 9 3s, 270 degrees. Then 5 pi by 6. 6 3s 18. So 3 5s 50, 150 degrees. So like this we will convert. Same 330 degrees you wanted to convert into radian. what you will do? 330 into pi by 180. Simplify. 3 11s, 3 6s. So you will get pi by 6. 210 degrees. 210 into pi by 180, which is nothing but 0 0 cancel. 3 6 6 threes. Sorry. 3 6s, 3 7s. You will get 7 pi by 6. You try these two angles and mention the answer in comment section. Let us move to the next slide. Position of an angle on coordinate plane is very important. Again, I'm telling you, position of an angle. Suppose I am taking some 130 degrees in a positive direction. So what I need to do? What I need to see? 130 is greater than 90. Just see here, this is 0 degrees, this is 90 degrees, this is 180 degrees. So you can tell very easily 130 is nothing but 90 plus, okay, 90 plus 40. So you can tell that that particular angle will come somewhere here. Hope this is clear. Suppose you are taking 195 degrees. Again, the sign is very important. Here the sign is positive. So you need to go only in this direction. 195 is greater than 180. So it will come somewhere here. Okay. So this is what the position of the angle. Suppose you are telling minus 35 degrees. What you need to do? You need to go in a clockwise direction. This is very important. You need to go in a clockwise direction. Minus 35 degrees. Minus 35 degrees. Okay. This is position of angle based on the sign. You need to understand. Okay. Let us see the next one. Trigonometric ratios of general angles. Just see here, I am taking a point over here. The point is P of x comma y. X is abscissa, y is ordinate. Remember, x is abscissa, y is ordinate. Then we learned something in our grade 10, like sine theta is nothing but opposite to theta by hypotenuse. Yes, you listened it correctly. So I don't have any triangle, but I can construct a triangle over here by drawing a perpendicular to the x-axis and by joining this to the center. So I can tell here this particular length is x units, this particular length is y units. Then I can tell the radius of the circle r is nothing but under square root x square plus y square. By using Pythagoras theorem, we can tell. Hypotenuse is hypotenuse square equals to base square plus perpendicular square. So we got the radius. Now sine theta you can define like ordinate divided by distance from the center. Ordinate. Here you are taking the angle theta. Okay. This is theta. Opposite by hypotenuse, which is nothing but y by r. R is the radius. You need to understand. Then what is cos theta? Adjacent by hypotenuse, x by r. Then what is tan theta? Y by x. Then what is cosecant theta? Cosecant is inverse of sine. So r by y. Okay. Then what is secant? Secant is inverse of cos. R by x. Then what is cosecant? Cosecant is, sorry, cot is inverse of tan, which is nothing but x by y. Okay, you may ask a question like, if you are taking a point over here, you are getting both values are positive. What if you take the point in the second quadrant? Okay, if I take a point over here, let me find a point over here. The point will be like minus x comma y. You should be very careful here. You are going to the negative side of the x-axis. Again, do the same thing. This is theta. Obviously, this is theta. Then signs will change. You need to be careful here. Wherever x is involved, abscissa is involved, all those will take negative values. See here, cos is involved with x. Definitely, the result will be minus x by r. Okay. Tan is involved. Again, minus y by x. Where is x is involved? Secant is involved. So you will get minus r by x. Cot is involved. Minus x by y. Which are not involved here? Only cosecant and sine. These two are not involved any x. Okay. In these two, we don't have any x variable. That's why we are not getting negative. Same like that. Here also. Here also. Any quadrant you take, will follow the same process. And see here, quadrant signs of the ratios. That leads the same thing in the previous slide what we have discussed. That is very important. How they changes the sign. How trigonometric ratios changes the signs if you are in a different quadrant. Just see, try to understand. You are taking a point over here. The point is p of x comma y. You can tell very easily sin theta, cos theta, all ratios are positive only. In the first quadrant, this is called Q1, right? Quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Here, when you drop a perpendicular and when you found the ratios sin x, sin theta, if you take here x already, theta is here. So take theta. Okay. Sin theta is opposite by hypotenuse, which is y by radius. Positive now. So all trigonometric ratios are positive in first quadrant. Then what about second quadrant? P of minus x comma y. What do you get here? Wherever x is involved, all those ratios will get minus. Wherever x is not involved, all those ratios will get y, mean positive. We know that sin theta is nothing but ordinate by radius, which is y by r. Then inverse of sin is cosecant. Cosecant theta is r by y. Except these two, remaining all ratios involved x variable. That's why remaining all will get negative. Just observe, only sin and cosecant are positive, remaining all are negative. Same like that in the third quadrant. If I take a point over here, the point is like p of minus x comma minus y. Okay. Wherever I have both variables, those two are positive, remaining are negative, because minus minus will be cancelled. One is tan. Tan is nothing but y by x. Cot is nothing but x by y. Except these two, remaining all are negative. Just observe. Then fourth quadrant, x comma minus y. Wherever y is involved, all they are negative. Y is involved in sin, tan, cosecant, cot, cos and secant. Here, cos and secant. These two are positive. These two are positive. Here, these two are positive. Here, these two are positive. So, how to remember this is very important. I learned my trigonometry like this. Here, all are positive. That's why I am writing all. Okay. Only sin and its inverse are positive. That's why I will write a code word here called silver. Okay. S represents the sign and its inverse. T, cups. All silver teacups. T represents tan and its inverse. C represents cos and its inverse. So we need to remember here one thing, that in the first quadrant, all trigonometric ratios are positive. Coming to the case of second quadrant, only sine and its inverse are positive. In the third quadrant, tan and its inverse are positive. In fourth quadrant, cos and its inverse are positive. Cos inverse is secant. Yeah. Let us see the next slide. Trigonometric ratios for quadrantal angles. Again, I am taking unit circle. Unit circle is nothing but whose radius is 1 unit. So this point I can tell, I can talk about this point. This point is nothing but 1 comma 0. X value 1, Y value will be 0. What do you tell about this point? This point is X value 0, Y value will be 1. What do you tell about this point? This point is negative side of X axis, 1 unit. No? So I can tell this point is minus 1 comma 0. So what do you tell about this particular point? It is 0 comma minus 1. We know that this is 0 degrees and 0 radius. This is pi by 2 degrees or 90. Sorry, pi by 2 radians are 90 degrees. This is pi or 180 degrees. This is 3 pi by 2 or 270 degrees. This is 2 pi or 0 degrees. 2 pi means 360. Okay. Now you just already we know the basic angles. What is sine 0? What is cos 0? Those we learned in grade 10. Okay. Sine 0 is 0. Sine pi by 6 is nothing but 30 degrees. 1 by 2 sine pi by 4, sine pi by 3, all this we learned. Just see here, sine pi. Sine pi represents this 0. Sine 3 pi by 2 minus 1. Okay. Sine 2 pi 0. So whenever you take unit circle, a particular values you need to understand. Pi 3 pi by 2 or 2 pi. These values on the axis. Y value is nothing but sine value. X value is nothing but cos value. Hope this is clear for everyone. Okay. Let us see one example here. If cos theta is 3 by 5, if cos theta is 3 by 5 and theta is not in first quadrant, we know if you take a xy plane, here all trigonometric ratios are positive. Here only sine and cosecant are positive. Here tan and its inverse cot are positive. Here cos and secant are positive. So they are telling cos is 3 by 5. Theta is not in first quadrant. Definitely theta will be in fourth quadrant. Hope everyone understood. Theta is in fourth quadrant now. Theta is not in first quadrant mean cos is positive only in two quadrants. One is first quadrant, second one is fourth quadrant. So we need to see now everything in the perspective of fourth quadrant. Clear? Now I want what is sine theta, what is tan theta, what is secant theta, what is cotangent theta. If I have cos theta is 3 by 5, just try to build one small triangle. I am taking theta here. Then what is cos? Actually, it is, what is cos actually? It is adjacent by hypotenuse. This is 3, this is 5. Definitely this will be 4 units by Pythagoras theorem, you can find out. Then find out what is sine theta. And remember which quadrant you are taking. Sine theta, we can find out from the triangle. Sine theta is opposite by hypotenuse. But which quadrant? We are in fourth quadrant. We know in fourth quadrant, sine is negative. So I will take minus 4 by 5. Then what is tan theta? Tan is 4 by 3, which is opposite by adjacent. But I am in fourth quadrant. In fourth quadrant, tan is negative. Okay. Then what do you tell about secant theta? Yeah, secant is inverse of cos, so no problem. 5 by 3 I can take. Then cot theta. Cot is inverse of tan, minus 3 by 4. Now I got all values, substitute them in the given question and prove, we will get the answer. Let us prove it. 5 into sine theta is minus 4 by 5. Okay. Minus 3 into tan theta is minus 4 by 3. Minus 4 by 3 divided by 3 into secant. Secant is 5 by 3. Okay, very good. Minus 4 into cot. Cot is minus 3 by 4. Okay. If I simplify, I can cancel here 5 ones, 5 ones, 3 ones, 3 ones. I am getting minus 4. Minus into minus will become plus 4 divided by 3, 3 will be cancelled, 4, 4 will be cancelled. In the denominator, 5 plus 3, minus 4 plus 4 will become 0. 0 by 8 is nothing but 0. So here, in which quadrant you are taking the trigonometric ratios are very important. Hope you understood how we took the minus here, here and here. First, you need to define in which quadrant you are going to take the ratios. Okay. Then, what is periodic function? What is periodic function? Periodic means which repeats. Which repeats. Any function of variable x, f of x, which repeats its values it is. In a definite cycles is called a period. Okay. Just see here, if I take a circle, we know that this is 360. If I take another round, again I will get 300 to the same point, to the same point, to the same point. So you need to understand, it is repeating continuously. This is periodic. Okay. Just to see this, it's a pattern, right? Repeating continuously. This is also periodic. You take any music rhythm, it is periodic, repeating in the same intervals, mean time intervals. Okay. Then how it is related to trigonometry? Just see this. I have given the diagrams of the all trigonometric ratios for you. If I take the sine function, just observe this portion. I will draw with another color. Okay. This portion is particularly repeating. After this, again, it will come like this. Okay. That's why sine function is repeating at every 2 pi. Sine function is repeating at every 2 pi. Then what do you tell about cos? Just see this. Cos function also is repeating at every 2 pi. Cos function also is repeating at every 2 pi. What do you tell about cosecant? What do you tell about cosecant? I am taking this particular section. It is coming here. It is coming here. Again, see here. So cosecant section also is repeating at a 2 pi period. Secant section also is repeating at a 2 pi period. Then what do you tell about tan and cot? But tan is repeating at pi. Pi means 180. Every 180 degrees it repeats. Just see. From here to here, it is minus pi by 2 to pi by 2. It is 180. Pi by 2 to 3 pi by 2. It is 180. Same like that. So it is very clear from these diagrams. Sine, I will write with another color. Sine, cos, secant, cosecant. These functions repeats with the 2 pi period. Tan and cot. These two repeats with the pi period. Okay. Yeah, these two we will discuss in a further topic again, because what if I have sine 3x or 5x, how it will repeat periodically, what are the values that we need to consider, those will come again in a topic called periodic functions. Okay, so we no need to discuss much about it. For a while, remember sine, cos, secant and cosecant will repeat with a period of 2 pi. Tan and cot repeat with a period of pi. Yes. Okay, then what is this domain and range? Domain and range. I told you sine 0 is 0. Sine 30, sine pi by 6 is nothing but 1 by 2. Sine pi by 4 is nothing but 1 by root 2. Sine pi by 3 is nothing but root 3 by 2. Sine pi by 3 means 60 degrees. Sine pi by 2, which is nothing but 1. Just observe, I gave some input, I am getting some output. I gave some input, I am getting some output. That input is known as domain. Okay, hope this is clear for you. The input is known as domain and the output is known as range. But we need to consider now, for every input we will get the related output in the sine trigonometric function. Okay, domain is nothing but whatever the input angle that you will give to the trigonometric ratio, that is known as domain. Then what is range? Whatever the output range that you get from very small to very big, that is known as range of trigonometric ratios. But we cannot find out like this for every trigonometric ratios. Just try to understand the small table. Here we can give any angle to the sine. That's why they mentioned here r. R means all real numbers I can give. What is the range? Minus 1 to 1. How do you know that it is exactly minus 1 to 1? Just now we have seen the periodic function. Just now we have seen the periodic function. It was like this. Okay. What is this? Upper limit. This is lower limit. It is x value. This is minus 1. This is plus 1. So this function oscillates between these two values only continuously. Minus 1 to 1. Okay. This is called a range. Even cosine is cosine also repeats in the same interval minus 1 to 1. Tangent, they have removed a particular value. Observe, they removed particular value 2n plus 1 into pi by 2. Pi by 2 they have removed for tangent. Why? See the diagram of the tan. Where is it? See the diagram of the tan function, how it is showing. At pi by 2 it is not having any value. At minus pi by 2 it is not having any value. At minus 3 pi by 2 is not having any value. At 3 pi by 2 it is not having any value. So it is very clear that tan pi by 2 is not defined. Tan pi by 2 is not defined. That's why they are removing that minus. From the all real numbers, you are removing that related multiples of this pi by 2. And what is the result? What is the result? You are getting all real numbers. Minus values, plus values, root values, everything you are getting. Okay. That's why the range is all real numbers. For cosecant also we need to remove some value, which is nothing but pi, n pi. We need to remove that because 1 by 0 is not defined, right? Okay, 1 by 0 is not defined. For cosecant sine 0 you take, sine 0 is 0. Cosecant 0 is 1 by 0, which is not defined. That's why you need to remove n pi. Then what do you tell about cosecant? See the diagram again. Cosecant diagram. Where is cosecant diagram? The graph, you just understand, remember the graph. See these two. We are having the curve over here, over here, over here, over here. But we are not getting any curve in this particular range. That means minus 1 to 1, there is no any value. So they are removing from the all real numbers this minus 1 to 1 range. Minus 1 to 1, we don't have in our range. That's why they removed it. Then secant also, cotangent also. Hope this is very clear. Yes. Go through the table. Try to remember the diagrams as it is. So it will be easy to understand what is the domain and what is the range of different trigonometric functions. Hope this is clear for everyone. If there is any doubt, mention in the comment section. I will give a reply in the next video. Thank you so much.